Ideas in STEM Ed is a production of the Idea Engineering Student Center at UC San Diego, which works to promote community, success, and inclusion at all levels. My name is Darren Lipomi, Professor of Nanoengineering and Chemical Engineering and Faculty Director of the Idea Center. The purpose of this podcast is to provide a forum for the discussion of innovative and inclusive approaches to teaching and mentoring, and to support the personal and academic flourishing and success of students in science and engineering. To learn more about the Idea Center, visit jacobschool.ucsd.edu/idea. Andrea Armani is the Ray Irani Chair of Engineering and Material Science and Professor of Chemical Engineering and Material Science at the University of Southern California. Her laboratory uses a mixture of tools from chemistry, physics, engineering, and biology and bridges the disciplines of material science, medical imaging, and nanophotonics. Among many awards she has earned over her career, she is the recipient of the Presidential Early Career Award for Scientists and Engineers, or PKs, in 2010, and recognized as a World Economic Forum Young Global Leader in 2015. Andrea is perhaps known as much for her scientific work as she is for her advocacy of students, young faculty, and women in science. She regularly organizes events stressing the importance of mentoring, careers in and outside of academia, and equity issues in science. We're honored for her to join us today.
Thank you for having me.
So role models are great, but what's an anti-role model, and what are some characteristics of anti-role models that influence your behavior?
Anti-role models are people who exhibit behaviors that you don't want to exhibit yourself. A role model obviously is someone you look up to, someone who's has accomplishments that perhaps you yourself want to achieve. And at least from my personal experience, I've been incredibly fortunate that both my undergrad advisor and both of my postdoc advisors were incredible human beings, like just fabulous. In developing my own mentoring style, I kind of took like little elements from their research groups and blended them into my own research group. Things like holding, a holiday party at, Christmas time, and then having individual meetings with my students. And then, really working one-on-one with my undergrads. And these were, it isn't as though my postdoc advisor or my undergrad advisor did all of these things, but I took, different elements that specifically resonated with me. And then there are the, anti-role models who have different behaviors and who exhibit things that perhaps you don't want to mimic. And one example is my PhD advisor kind of left all of his students to fend for themselves. So when giving a conference presentation, like my first conference presentation, I got a lot of help from my lab mates in terms of practicing it, in terms of, making sure my slides were logically organized and I did a good job. And I had a lot of support from, my team members, but I felt somewhat unsupported from my advisor. And that was an example of something I never wanted my students to feel. I always wanted them to feel like, I had their back. And I think that's something very important for students to know, that, no matter what happens, like I'm going to be there for them. I am their, kind of like line of defense if something goes wrong. And, if I hadn't had that experience in grad school, I don't know as I would be as aware of that feeling. So I think on one hand, it was very stressful at the time, but I think having that experience, really shaped me into the advisor I am today. I wish there was a way, that you could train advisors without having bad experiences. So maybe having a discussion is good, right?
Yeah. One way to train advisors, and this is something that you have hinted at in other public talks that you've given, is to request feedback from your advisees. And what are some things that you've learned from your advisees that influenced your mentoring style?
So one of the biggest surprises I got from my advisees, and actually it's an advisee who's now a professor, Mark Harrison. He asked, so I have an annual review, and my advisees kind of review the research group, and it's anonymous. They review the research group, they review, the lab, the university, the department, as well as me, in a very lengthy survey. And then, there's kind of an open box that's like, anything else, any other suggestions you have? How can I help you? And sometimes there have been, comments like free food is awesome. Just like general big picture things. And then, one year, Mark, and the only reason I know is because he fessed up. Mark asked if we could do like annual performance reviews, where I would sit down with each student and kind of tell them how they were doing, how their progress was going, if there were things they could do better, things that they were making good progress on, just so they could get a sense of how they were doing in their PhD. Because unlike an undergrad where you have like a clear curriculum, clear goals, what your GPA is, as a PhD you can tend to feel a little lost. And in a job you have annual performance reviews, so it actually makes sense to do this. So we started annual performance reviews in my group, and it's worked out really well, and it was a great idea on Mark's part, but that was kind of an idea that came from him. And it's also been really helpful to kind of do this annual review of the students and me, because as the group has kind of changed, right, because every year we have new students come in and students graduate, what they've really wanted to do has also kind of evolved. Sometimes the students really want to have parties at my house. Sometimes they would much prefer to have them on campus. So we kind of evolve is what the group wants to do.
You've been a mentor to a lot of people, both in your group directly, but also to the community. Your lab website used to have a very extensive list of essay topics. I've noticed that it still does. That I saw the FAQ, which was designed for people joining the lab. So that's great to see. That was a great resource when I first started in 2012. Why did you feel compelled to make all of that information public?
First off, all that information is still on there. I recently did like a whole lab page reorg, and it's all under now like an advice page. So it's a little, I thought, easier to navigate, but maybe I'm completely wrong. But I tried to consolidate everything into like one page.
Okay, perfect.
Yeah. But yes, everything is still there. I decided, so I made everything publicly available because I really feel that transparency is important. And also when I was an undergrad applying to grad schools, I was incredibly lost. And because I was the first person in my family to actually get a PhD in science. And so I didn't really know what I was supposed to be looking for, what type of questions I should be asking, how to gather information. And so I wanted new students who were thinking about joining my group to have the answers to these questions, as well as think about what questions they should be asking other professors, and especially students perhaps from first gen backgrounds who may not feel comfortable asking me questions. I would just give them the answers, so then they wouldn't need to ask me questions that maybe they feel a little awkward about asking, right? So I would try to open the door to the discussion. So it was a lot of reasons.
Mm-hmm. Do you feel that making this information public makes you more, I guess, vulnerable is the word of the day? But do you think it lowers the level of mystique that a professor is supposed to have, that is somehow deleterious if we remove these barriers?
I'm sure it does. But on the other hand, it probably changes the type of student that applies to my group. But my group is also really friendly. So the students that do apply are students that value kind of the open culture in my group, in the sense of transparency and the sense of teamwork. And perhaps, if I didn't have this very open communication in my group, a different type of student would apply. And it's not necessarily the type of student I want in my group. I want students who really believe in teamwork, really believe in, everybody helping each other. So it's, it helps to facilitate, my recruiting students that I want to recruit. Am I supporting that type of student?
So speaking of transparency, your Twitter is one of my favorite ones to follow. I feel that you never waste a tweet. There's always something that's poignant in your tweets. If you had to give your Twitter account a subtitle, what do you think it would be?
One of my friends always jokes that half of my tweets are me venting, and the other half of my tweets are pictures of my cat. And it kind of oscillates back and forth between like Andrea venting and Andrea's cat. So I'm not sure which half of the tweets you really like. I have a feeling it's not my cat pictures.
I am a cat person.
Okay. Yeah. So it would probably be something like, the venting of Professor Armani. But I have heard that a lot of people really find my venting funny because it's more just spewing about everything that frustrates me.
I feel it's very, very honest and probably is probably actually a good recruiting tool too if you are trying to shape the applicant pool in a way that responds well to openness and trust. And I can see that that the climate in your lab must be very strong for you to be able to do that.
I mean, it also has helped me reach out to a lot of new assistant professors at USC and really help shape, not just the culture in my lab, but especially a lot of the new assistant professors who are coming in and just getting started. And when I was an assistant professor at USC, a lot of the senior faculty who have now retired were really instrumental in helping me get my lab off the ground. Because that first semester, sometimes your lab is done, sometimes it isn't. Getting new equipment in, you can be really resource limited. And it's hard for senior faculty to know who's coming in. So it's been very helpful for me to meet a lot of the new faculty, especially in other departments, that I might be able to help. So I found it incredibly useful in that sense, just to try to help nurture these, new baby faculty and help them launch their careers.
Is that how you think you got the reputation of being a great mentor?
I mean, I think you get a reputation of being a good mentor just by being a good mentor, right? Just by helping people and trying to, pay it forward, right? If you help people, then more people come to you for help. And then you help more people, and then more people come to you for help. And then it just continues.
In your own lab, where do the ideas come from? Where do research ideas come from?
Everywhere. I'm sure you get asked this question a lot too, right? But they come from the students, they come from me, they come from, we have collaborators everywhere. So they come from, honestly, just all over the place. One of kind of my graduation requirements, I have 3 requirements for a student to get a PhD in the group. One of them is that they have to do a little bit of experiment and a little bit of theory. The relative balance between those two is entirely up to the student, but I think it's really important for a student to do a little bit of both. A student has to build something, whether it's a testing setup or a modification to a testing setup, but I think it's important for a student to design and build something, and that creates a skill set. It also teaches you, how to take different things from different manufacturers and make them work together, and then how to deal with like software, hardware incompatibility issues, and also builds confidence in yourself that you can actually do this. And that confidence building, I think, is really important. And then the third thing is a student needs to come up with their own idea for a project and see it to completion. It's super easy to come up with an idea and get the first experiment and be like, yay, it worked, and then drop it. And because that first experiment's always a super exciting one. It's the replicating it 50 times and then actually writing the manuscript and then getting the manuscript published. That's the not fun part. So that last thing is usually what a student will spend their last year and a half doing, is coming up with like their own idea and then seeing it through to completion. So usually at any given point in time, about a third to a quarter of my group is working on their own ideas that they've come up with. And maybe those are just extensions of existing projects, but I really feel that the idea of being able to come up with an independent project is really important, because when a student leaves the group with a PhD, they're going to go off into the world and they're going to be a team leader. I'll help them, but they're kind of independent of me, and they need to be able to lead by themselves. So I kind of have those three requirements.
So what characteristics do you look for when new students are applying to your group?
I look for a range of characteristics, really. I look for students that have skill sets that complement the current students' skill sets. I look for students that have done team-based things, whether it's being, in a student club, whether it's, being on a sports team, but something where they actually had to work with others. I look for some sort of lab experience where they were an experimentalist. It doesn't necessarily have to be of a similar nature to the work we do in the group, but I at least want to see some sort of lab experience, simply because it's, doing experimental research is incredibly frustrating. To be completely honest, things fail a lot. And it takes kind of a certain mentality to be able to handle that constant failure and pick yourself up and keep going, and have developed kind of the mentality that if the experiment fails, it's the experiment failing, not me failing, and separate yourself from your research. And so I want to make sure that a student has kind of either developed that, or they're on the path of developing that mindset, and also that they enjoy it. And they're able to recognize that just because an experiment doesn't work, that doesn't necessarily mean that there's nothing to be learned. Because if you design an experiment well, you can always learn something, even if it doesn't work. So I like to see a student that has done some experimental research and actually enjoys the process. So I look for lots of things.
How do you assess those characteristics in a short meeting during graduate recruitment?
So I usually ask a student what their favorite research project was. And it doesn't, and I ask potential postdocs the exact same question. And I'm usually not looking for them to say, oh, my favorite research project was the one that got published. Because, for example, my favorite research project from my PhD it never got published. But it's still my favorite research project. It combined a lot of different fields. It made this really cool device. In the end, we just were never able to test the device, because whenever you make a new device, a lot of times you have to make a new testing setup in order to test the device, and we could never get the testing setup to work. So it was an awesome device, but I still don't know if it works. And it's been like 20 years. So I'm always curious what somebody's favorite project was, why it was their favorite project, what about it made it their favorite project, what really excited them about it. Because you can learn a lot about a person's, personality by what really makes them excited. And maybe it was the team that they were working with. Maybe they really liked their, collaboration partner. One of the reasons I really like that project is because I got to collaborate with a bunch of chemists. So you can learn a lot. So that's one of the questions I ask.
So from the student's perspective, one of the questions that an undergraduate applying to grad school is likely to ask is, by what relative weight should I give the prestige of the university versus the PI and the PI's ability to mentor? And I have a feeling I know what way your answer is going to skew, but I'd like to hear the whole range of argument.
So I always say that the PI is the most important, simply because the PI is with you forever. Your PI will be writing you rec letters for decades to come. I've had grad students leave my lab, then go take jobs in industry, and then 5 years later say they want to become professors, and then I'm writing them rec letters for faculty positions, or they come back and say they're changing industry positions and they need another rec letter. So it's very important to have a faculty member that's really invested in you, not just invested in you as a little busy bee during your PhD and then they kick you out and they're done with you. And so you really want someone who is your mentor for life, not just your mentor for 5 years. Obviously, academic institution is important. I'm not going to say it's not important, because academic institution is related to what type of facilities you'll have. You need to have sufficient facilities to actually do research, but it's a matter of like your long-term vision versus a short-term vision, and so there needs to be a balance between those two. Kind of one of my favorite anecdotes was at chemical engineering at Caltech. They admit all of the students, and then they do rotations their first year, and then they do like a matching program at the end of the first quarter. And they admitted about 25 or 30 students during the first year, and about half of them wanted to work with this super famous professor, and he was only planning on taking one student. And all of these students are clearly very smart. But it meant that the majority of them ended up not working with the person they wanted to work with, which is kind of sad, because they could have gone to another school, they could have worked with the faculty member they wanted to work for, and now they're at a really great school, but not necessarily doing the research they want to do, and not necessarily working with the professor they want to work for. So I always encourage students to make sure that they're going to get that match that they want from the get-go, and not end up in that not ideal position.
When somebody applies to USC and they're accepted and they're interested in your lab, but you have too many applicants, which I'm sure happens a lot, how do you tell the qualified students that you would take if you had all the resources, all the personal bandwidth? How do you tell them no, and what are the reasons that they did not get the position despite being accepted to USC?
So actually, USC I think is a little different than UCSD. So students, at least in the majority of so I am cross-appointed in a lot of different departments. So in the majority of the departments I'm appointed in, students are accepted to both the department and the faculty members group. So they're admitted directly to my group, so they know that they're in my group. The exception to that is the chemistry department. So the chemistry department does admit as a cohort, and then do kind of this rotation program, and then does matching. If a student applied to the chemistry department, I can usually accept like one extra chemistry student. That's not going to be a huge burden. But I can imagine if I had 7 students who all of a sudden wanted to join my group, that could be an issue. But I don't necessarily have the problem of a bunch of students applying, getting admitted, and then I have to. In contrast to a department like that, I actually have a lot of those conversations in December and January. In my admission process, I kind of come up with a list of the top 20 students, and then I circulate the CVs to my current students, and then my current students actually weigh in. And what is very interesting is, by the time I've down selected to the top 20 students out of all those departments, all the students are equally fabulous. If I had to pick by myself, I wouldn't be able to. I have problems just getting to 20, which is why I originally started asking my students, was because I really needed help. But then when I ask my students, they all converge on like the same 5. Like every year, they all converge on the same 5. But what's really interesting is their reasons for those 5 are always different. It isn't as though they're all converging on them because of GPA or because of past research experience, but they all find different reasons for the same 5 students. So it actually, as long as I can get to 20, they can get to 5. So it's interesting to see what my students see in the students that perhaps I didn't see.
That's a wonderful way to see diversity manifest when you outsource an important decision like that to not that you're outsourcing it, but when you solicit feedback from a diverse group, that multiple characteristics are highlighted.
No, it's great. And so then, after that, I talk with those 5 students and make sure they're, genuinely interested. And then, I tell them to reach out to my current students. And so then it ends up being not just me recruiting them to USC, but it's really the entire research group recruiting them to USC, into my group.
In nanoengineering at UCSD, in nanoengineering and chemical engineering, we have a direct to PI sort of recruitment, but then in material science and chemistry, they're recruited as a cohort. I don't have as many department affiliations as you do, and I'm wondering how you manage that. Do you get asked? You must get asked to be on lots of exam committees, departmental committees. How do you manage it?
So lots of exam committees, especially because my primary appointment's in chemistry and material science, but my research is very electrical engineering. So for the electrical engineering students, I qualify as being an outside member, but I understand their research, so they don't really have to worry about me coming in with some weird sideways question that they don't understand. So I'm on a lot of EE committees, which I enjoy. I collaborate with a lot of the students as well. So that's, kind of expected. But as far as normal service committees like faculty recruitment or something like that, all of those are limited to just my department. I do have, so USC actually has a faculty mentoring program where senior faculty mentor junior faculty. And I actually right now have 5 assistant professor mentees. So I have like a little mini research group of my assistant professor mentees, which is really nice.
That's a lot. Five is a lot.
I have them talk to each other, as well as, having individual lunches with them. So 2 of them are in biomedical, 2 of them are in chemical engineering and material science, and then 1 of them is in the School of Medicine. So it's actually really good because they're in different departments, so they can talk to each other and kind of compare how their departments are treating them, the different department policies, as well as teaching loads, so they can, really get perspectives from outside of their department, as well as just get advice and kind of vent to each other about assistant professor things. And then also, I give them advice on career advancement. 2 of them are going up for tenure this year.
Oh, fantastic. When you get invited to an exam committee on a topic that is quite outside your field, do you have a trove of questions that you draw upon? Do you have favorite topics that are evergreen and universal?
So I don't really have favorite topics. So usually if it's one of the completely outside of my field, then that means it's also outside of my department. And one of the pieces of advice I got early on is that if I'm the outside committee member, my job isn't so much to be a committee member and ask the student questions. It's really, I'm there to be a referee for the faculty. So my job is to make sure that the faculty stay in line, and then the faculty's job is to ask the students questions. So as the outside member, I can ask the student questions if I have them, but I don't really need to. I'm there to make sure that the faculty behave themselves and don't get out of line. And I've only actually had to play that role once, but it's really just, sometimes I ask questions. I ask a lot of the chemistry students about the materials they make, things like, so is it stable in air? Have you tried to test this in thin film? How do the behaviors change in air? And all the chemistry students now know I'm going to ask that question because I'm curious if I can take their material and use it. So I'm not really asking just to be mean. I have a personal interest in.
Yeah, you want to learn.
yeah, I want to take their material. So they kind of all know this question's coming because they talk to each other and they're like, yeah, Andrea's going to ask you if she can use it. So you either better say we're going to test it or you better have an answer. But that's really the only question I typically ask when I'm out of field.
Exam committees strike me as one of the few scenarios in our jobs where the teaching component and the research component are really combined for an hour or 2 hours. I wonder if you think the modern university system has the right balance, say at an R1 institution, between teaching and research. Should teaching be left to specialists? Should vice versa for research? How do you feel about that?
So I think that a lot of the more like undergrad basic classes should probably be left to teaching faculty who really love teaching. And that would kind of free up a lot of the research faculty to teach more technical electives. So for example, for undergrads, I teach a nanomaterials class, which is a lot of fun to teach. It's in my wheelhouse, so I know a lot about it. And it's still an undergrad class, right? So, I mean, I'm still very research active faculty. I'm still teaching undergrads, but they're getting the benefit of the fact that I'm teaching them stuff about my research. I think by freeing up my time, because we recently hired a teaching faculty member, it then allows me to develop classes that actually are stronger for the undergrads. Whereas if I had to teach mass transport, the undergrads wouldn't have that class as a tech elective. They would really be limited in what their course selection would be. Mm-hmm. So I think trying to strike that balance, as far as saying, we just, should hire a bunch of teaching faculty and then let the research faculty just go do research. I don't think that's necessarily appropriate. I think we should really, take it as an opportunity to let the research faculty teach students about the research, right? And really, develop courses that leverage all of this knowledge that all of the research faculty have to enrich the education of the students.
Are there examples of having taught a course where the fundamental knowledge that you had to convey that may or may not have been new to you, but opened your eyes to a new research direction? Has that ever happened?
Yes. So all of my degrees are in physics, and I'm teaching chemical engineering and material science students, and occasionally a random BME undergrad. So I'm teaching, a nanomaterials class, but, coming at it from kind of a physicist perspective and then introducing chemical engineering and material science. But then they're coming at it from their chemical engineering undergrad coursework. So their questions are very chemical engineering driven. So it's this very interesting kind of mind combination of they'll ask a lot of kinetics type questions. How will the kinetics govern the reaction? Is there self-quenching? So they're asking a lot of chemistry driven questions, which then has in my mind raised questions about, so what is the nucleation energy of this particle formation? Can we start controlling that? Could we do nucleation on the surface of our devices, which is then led to like that entire line of investigation, which I wouldn't necessarily have come up with if I was just sitting in my office. But you have all of these, just minds that, they have questions and they ask, especially if you have, interdisciplinary classroom where you're really encouraging questions and encouraging discussion and teaching them totally new things.
It's great when people's different priors come into one environment and see what what it looks like when somebody with physics training versus somebody with chemical engineering training, they look at problems differently. I think we're gonna switch topics a little bit here. How has COVID affected your career and or priorities in life and research, or however you want to take that?
Yeah, it's interesting you ask, because my husband and I were actually just talking about this with some friends the other night. So before I'm an academic, my husband's in industry, and he's also an engineer, and we very much led like separate professional lives, not separate lives, but separate professional lives. And last spring, our lives definitely merged together. So one of the big challenges that USC kind of posed to all of the engineering faculty was, step one, hand over all of your PPE to the hospital. Just give it all. And then step two, like if you have free time, can you help us, do things like 3D print face shields? And, also, do you have any like UVC sterilizer systems? And so, my husband, who again is in industry and actually does like manufacturing, he and I teamed up and I designed a system, and then his company, he has a small startup company, they actually manufactured about 40 of them. And because his company's in defense, so they actually never shut down. So it was, it completely changed like my lab's priorities. It completely changed his priorities in terms of like our research focus. So it was, and I actually went back into the lab, which like I did an experiment.
That's fun.
Yeah, like I like cultured bacteria and then did an experiment to make sure that the system worked, and to determine the duration of exposure and things like that, which was shocking. I still have skills. So that was a lot of fun. So it did completely change like those types of priorities for several months. And then it also has really changed, my opinion on travel in a big way. So before this past year, the longest I had been home since I was a postdoc was about 2 months. And that happened when I had shoulder surgery. And I had a major shoulder reconstruction, and I was home for 2 months. I flew with a brace on, like that level of travel. And so this has kind of been a real awakening to, what, maybe we just shouldn't travel for NIH panels. Maybe I don't need to take like a red eye to DC, sit on a panel for 10 hours, and then fly back to LA.
So which category of academic travel would you retain?
So I would say, I would do a better job of scheduling. So for example, like if like both NYU and Columbia invited me out to give seminars, and one was like, yeah, how was February? And the other was, so how is April? I'd be like, you know what, you two get together, because I'm going to fly to New York once. And if you two can't work it out, I'm out.
Yeah.
So it would be things like that. Like I'm gonna cut down on the flights. Reduce just multiple trips. Just because it's been really nice. I don't know about you, but it's been really nice being healthy. It felt like the last 3 years I was just sick all the time. Like it would be like I'm really sick, and then I'd kind of get better, and then I get really sick again, and then kind of get better and really sick again. And suddenly the last year I've been healthy, which I feel really guilty about, because I know a lot of people haven't been, but I actually have been healthy.
And you also have control over your sleep, no jet lag. You have control over your diet. You have control over your exercise. You're not exposed to new pathogens, twice a month. There are also, it's a bit of a double-edged sword. Pre-pandemic, there would be debates about, occasionally, like clockwork, you would have some senior PI say, I'm done with travel. And then you would have, this is on Twitter, then you would have 20 comments saying, easy for you to say, you already extracted all of the benefit early in your career, and now you're telling us not to fly.
Right.
However, the equity issues go in both directions a little bit, because the expectation of young people traveling, they're not around to build up their lab. If they have a family, they have to be away from their family, and I think this has allowed us to reimagine it in a way that works for individual people. I think there are still going to be people who are going to fly 100,000 miles a year, but not as much. And I think we'll feel like we have more agency over it.
Yeah. So I'm about to talk in a circle, just to give you a heads up. So I can imagine still having hybrid conferences, because there's a lot of people who, when they go to conferences, they just can't afford to, right? And having hybrid conferences, for example, it has allowed a lot of my PhD students who normally I wouldn't pay to go to a conference, because going to a conference is really expensive, right? And you have to pay for flights, you have to pay for hotels, and maybe there's only like one session of talks that they're really going to benefit from. So why am I going to send 10 PhD students to a conference? Like that's a new laser. So there's just, it doesn't make sense. But if they can, all go sit in a conference room, all watch, the hybrid talks from that one session, that's awesome. I'll pay $100 a head for them to do that, as opposed to $1,500 a head, or it's order of magnitude. And the same thing is true, even greater, for groups of students from China, India. You also can avoid visa issues. So the hybrid format, I can easily imagine enabling a lot of researchers to engage and stay on top of state-of-the-art research. So for that entire demographic, the virtual online format is truly transforming their ability to engage. Then you kind of have the middle layer, the assistant professors, the postdocs who are trying to become assistant professors. They really need that in-person interaction for exactly the reason you said, to try to network with people who are going to be writing their tenure letters, or going to be hiring them. But then there also, conversely, is that work-life balance issue, because it's really exhausting traveling all the time. It is a really big, tug on your career, and your home life. My husband and I made an agreement I would be home every Friday night. I did a lot of trips to China and trips to Europe where I was on the ground for 24 hours or 36 hours so I could make it home by Friday night, because that was our deal. So there's that. And then you have, the, associate full professors who are kind of like, what, we're tapping out. We're going to, go more hybrid. Maybe instead of going to 12 conferences a year, we'll go to 4 or 5. So I think what's going to happen is, instead of having as many conferences or as many seminars or as many workshops, some of the ones that were less fruitful in terms of engagement between junior faculty and senior faculty, those are going to go away, because if the senior faculty aren't there, the junior faculty aren't going to go anymore. And if the senior faculty aren't there, then the whole thing will be virtual, and eventually the whole thing will just dissolve and go away. Whereas the bigger conferences where everyone will still go, those are going to become even more important. So I think, because kind of over the last 5 years, at least from my perspective, there's just kind of been this explosion of the number of conferences and then the number of sub-conferences, and it's just kind of gotten a little out of hand.
Yeah.
And I think we're going to kind of go back to having fewer conferences that are actually meaningful events. And we aren't going to feel like we need to go to everything. But I think that hybrid is still going to be there to enable students to go, especially undergrads. It's been awesome for my undergrads, because they can go to talks and not miss class.
Yeah.
Who knew?
Yeah.
It's amazing.
We can give talks and not miss the class that we're teaching.
Yeah. That's also great.
Tell me about the clean room that you are building at USC.
Yeah. So there are actually now students in the clean room.
All right, it's built.
It is built. Yeah, so for about the last 5 years, we have been building a clean room, from building a new building all the way to designing the clean room, and then building out the clean room, and building in all the infrastructure for it, and then buying equipment for it, as well as relocating some older equipment, and then certifying it with permitting. And then now, actually 2 weeks ago, we started training students to go in. So obviously there's kind of 2 categories of students. There's the existing users that had used our previous facility, and then the new users, so who've never set foot in a nanofabrication facility before in their lives. And those are 2 very different categories of users. So the existing users are, all trained. They're in the clean room using it. They're all super happy little researchers. And The new users are now trained on how to like gown up in bunny suits and how to use a fume hood, and they know the clean room fume hood protocol, and they're now starting to get trained on all the different pieces of equipment. So it has been a long process. It's about a $25 million clean room.
Wow, that's incredible. And you pointed this out to me before, so I'm not going to claim credit, but you are one of two women who are clean room directors at major universities. Why do you think that is? And I wonder if you could speak to equity issues for women in science in general, and take that whatever direction you'd like.
So usually clean rooms are managed by EE faculty. So nanofabrication came out of the EE department. And so it makes sense that usually a nanofabrication facility director, the faculty member director, is an electrical engineering faculty member. And in electrical engineering, there are very few women faculty. And usually you're going to want your director to be a full faculty member, so full professor, because as the director, you have to deal with a lot of faculty complaints. And it would be kind of an awkward position to put an associate professor in, and an inappropriate position to put an assistant professor in. So now you're kind of narrowing the scope even further, because you want to have a full professor, and then the number of full female faculty in electrical engineering is very tiny. So it's honestly, it's a numbers game, right? Like, how many full professors are there in electrical engineering who are women? So that's pretty much it,
Yep.
Unfortunately. So now, as far as equity issues, so with our clean room, I haven't faced that many issues, that many problems. We have a really good set of faculty here. Also, a lot of them realize the magnitude and the challenges, so the scope of the work with building a new facility. And they've been really supportive of everything that's going on. I know I am incredibly fortunate to have their support over the last 5 years. Just incredibly lucky. I can't speak for all clean room directors. I know Shia Feynman at UCSD. He was a previous director of the facility there. He's been a great resource for me in terms of trying to come up to speed on how to do this job and how to do it well. So I have called him a lot to get advice.
That's wonderful to hear.
Yeah.
In our last few minutes together, I have a couple of questions that may not seem like rapid fire questions, but they probably will necessitate a rapid fire response. What is the biggest thing you would change about academic science and engineering if you could?
Honestly, I would get rid of tenure, which is a big thing. Yeah, I think it's kind of an outdated concept, and also it has been, it's not really a useful thing anymore. The idea that tenure is held by a university doesn't make sense, because the whole idea of tenure when it was originally invented was that you would be tenured and you would have some super rich guy, let's be honest, super rich guy, give you a ton of money, and then you would be able to do whatever you wanted because you would have all this money to do your research. Now you have to get money from a funding agency. So really, your tenure isn't held by your institution, it's held by the NIH or the NSF or whoever's giving you money. And you don't really have academic freedom, because you have to get the NSF or NIH or DoD to give you money. So like, tenure as a construct is totally like not a thing. So we should just get rid of it. Like, it should just not be a thing. It should just, yeah. Yeah, people just abuse it. And they don't use it for its original intent.
Well, it does lead to a lot of old people on faculty committees making it very difficult to make obvious changes to curricula and department policies.
No, it leads to a lot of bad behavior. And it also leads to a lot of inequity in terms of distribution of work. So the balance between like service, teaching, and research. So it leads to a lot of inequity in terms of that. So I think you just shouldn't have tenure. But that's a very controversial opinion. But yeah, it is why I will never be dean of a university.
Speaking of controversy, what is your least favorite argument that appears in your Twitter feed with some regularity?
I would say a lot of the arguments around like PhD student stipend and postdoc stipend. I agree that PhD student stipends should be higher. I disagree that it is entirely the PI's fault. Everybody blames the PI for everything, and we don't set the stipend. So you can't blame us. I can't pay my grad students anymore. This is not my fault.
Yeah.
I would pay you more if I could, but I can't. This is what the university negotiates with the federal government.
There is a related issue around payment for undergraduate researchers, whereas the inequity there is not that undergraduates generally don't get paid during the academic year that they often do in the summer. The bigger inequity is that graduate students get paid at a 50% rate. And to pay an undergraduate researcher the minimum salary or hourly wage that I can means that the undergraduates that I pay this summer are technically making more per hour than the grad student who's mentoring them. And that is, I think, a source of misunderstanding. It actually came from a good place in terms of university as a rule saying you can only hire an undergraduate researcher at this minimum level. But then the grad student who's mentoring them is only a 50% employee.
But then you're also paying the grad student's tuition. So the other option is you give the grad student tuition cash, and then they pay taxes on that, and then they have to pay the tuition. So I think that often just gets forgotten.
Yeah.
That, you're paying their tuition because they just don't see the money.
All right. Trail running or road running?
Neither. I run on a treadmill.
Oh, yeah?
Yeah. So I actually had ankle surgery when I was an undergrad. So I played soccer. And I tore my Achilles about 3/4 of the way in one incident. And then in the next incident, I tore a bunch of the other tendons kind of going across the top of my foot. So then after the second injury, I had a complete ankle reconstruction. So I am not allowed to run on uneven surfaces. That is the official statement from my ankle surgeon. So I get to run on tracks or treadmills. And going around in circles is super boring, and I lose count also. So I run on treadmills, and then I can at least watch TV and distract myself from the fact that I'm really bored. Yeah.
Well, it's a good way to binge certain TV shows. All right. I have one final thing. If you were not a professor, what would you have been?
When I started grad school, I wanted to go work at a national lab, or maybe something like Bell Labs, which at that point in time was like the cool place to go work, because it was like late 90s, early 2000s. But so that was kind of my plan. And then I TA'd, and I really liked teaching, so then I shifted over. But yeah, so that was kind of my initial plan, was a national lab type position.
Awesome. Well, thank you, Andrea, so much for doing this. I learned a lot from this discussion, and I think our audience did too.
Thank you for having me.
Thanks for listening to Ideas in STEM Ed, a production of the Idea Engineering Student Center in the Jacobs School of Engineering at UC San Diego. This episode was edited by Darren Lipomi, with theme music written and performed by John Viviani. Title art was created by Caitlin Wong. The Idea Center works to promote community, success, and inclusion at all levels. To reach us for guest suggestions and other feedback, please send an email to ideadirector@eng.ucsd.edu, and to learn more about our programs, visit us at jacobschool.ucsd.edu/idea. As a final note, the views expressed by me or the guests do not necessarily reflect those of the Idea Center, the Jacobs School of Engineering, or UC San Diego. See you next time.